All right, everyone. Today we're going to take a look at solving equations that have absolute value symbols. This is a type of symbol or operation that you might already be aware of. Try to think for a second in your own words, or maybe using at least some descriptors. Can you describe what is an absolute value? Well, depending on what you came up with, there's a couple different things we need to know here. One is that the symbol itself, which you can see a bunch of below, is those two vertical lines. And what those two vertical lines do is they tell you the distance from zero. So most often people talk about the answer being a positive number, and that's true because distance is a positive quantity, but it's important to know that it's telling you the distance it is from zero. So when you see something like the absolute value of -3, you're being asked to figure out what is the distance -3 is from zero, and that is 3 units. That's why when you simplify it, you get 3. So most of the time, it's turning a negative into a positive because that's giving you the distance. If there were just a positive number under there, like 5, you would kind of keep it the same. Um, before we can look at solving equations, we need to look at evaluating absolute value expressions. So with all of these, what you're going to do, if there's any math in there, you need to follow order of operations first, and then you're going to take the absolute value by making your final result positive. So try every single one of these. You're trying to get to a single number answer without absolute value, and then come back and check your work. So for B, this is pretty straightforward. The distance -2 is from 0 is 2 units. Same thing with C, that is also 2 units. So as you can tell, when we take the absolute value of opposite numbers, we get the same result. For D, you need to evaluate the math, evaluate the expression in there first. So -3 plus 5 is +2, and the absolute value of 2 is the same as it was above. This is 2. Down here, you would do order of operations, so you'd multiply first. Then you would tackle 9 minus 11 and get -2. And then take the absolute value and get 2. So it turns out, answer to every single one of those was 2. Now, when it comes to solving equations, the interesting part here is this. Remember, you can put in any number you want for a variable, and you're trying to figure out what value of x would make the equation true. So what this is asking you right here is, if you could just plug in a single number for x, what could you plug in to make it equal to 2? As you should be able to see from these two examples above, there's actually two different possible answers. You could plug in a -2 for x, and you could plug in a +2 for x, and both of those would definitely work. Okay, so as it turns out, we're going to actually have two answers here. X could equal 2, and x could equal +2. What ends up becoming difficult with these is that most of the time we have two answers, but it's not as simple as simply writing down two opposite numbers. Sometimes that'll work, as it did in this example A, but not in all of these. So here's your basic setup that you're going to do. The whole idea is, because what's inside the absolute value can equal a positive number or a negative number, your setup is that you're going to set up two different equations. You're going to set up one equal to the positive version of the number we have on the other side, and one equal to the negative version. So here we start off with x, absolute value of x plus 1 equals 2. Well, you know that if x plus 1 simplifies to 2, that'll work. But if it simplifies to -2 when you take the absolute value of the n, that'll also work. So the two equations you're going to solve are written right here. X plus 1 equals 2, and x plus 1 equals -2. All you're going to do is solve those both independently from each other, and you'll get two answers. Now, what's interesting is these answers were not opposites, but if you plug the numbers back into check, 1 plus 1 is 2, and the absolute value of 2 is 2. -3 plus 1 is -2. Absolute value of that is also +2. Okay, so they should work when you plug them in. So for both C and D, again, try the same setup steps. Remember, you're taking whatever's inside your absolute value, setting it equal to a positive number, equal to a negative number, and then solving them both independently. Try C and D, and then come back to check your answers. So for C, you should have set up two equations, 3x equals 12 and 3x equals negative 12. You solve both of those the same way by dividing both sides by 3. This one you get x equals 4. This one you get x equals negative 4. So again, we went back to those opposite answers. That wasn't true in B, but it was true in A and C. I think in D we're going to see something a bit different. 2x plus 1 equals 3, and 2x plus 1 equals negative 3 should be the equations that you're looking at. Subtract 1 from both sides, and you'll get 2x equals 2. Divide by 2, and you'll get x equals 1. Do the same thing over on the equation on the right. Subtract 1 from both sides, and you get 2x equals negative 4. Divide by 2, and you get x equals negative 2. So the big key with solving absolute values, it doesn't matter what's inside your absolute value at all. All that matters is that you're going to break this up into two equations, one equal to the positive version of the number and one equal to the negative version of the number, to account for the fact that absolute values can make negative numbers positive after you follow order of operations.